Okay, so let's take a look at this hot mess of what I'm dealing with here. Personally, I just kind of started with this. I thought that was cool. It works really good for the first 2 weeks and everything. It's got this vegetation, sex phase, bloom phase out here in the figure four, where it's still quintessence or quantized as a small plant at that point in time, but it's starting to equal into that veg phase, and this could be arguably a plant, maybe a small plant, a plant, seedling plant, seedling. What did I say? Seedling, small plant, plant, small plant, plant. Starts to get a little weird inside of there, right? Why? Because reasons. When you're writing all this out, this is kind of the end of that series. This is really all that they could be if you put them against the wall, if you raised them up. If you had the first, you would get this cross, but you could also arguably get some other sets out of there, and that's because of the relationship of how they act independently when you're saying that these two things are the unknown, realistically, this thing and this thing, but they will equal essentially this on some type of rotational symmetry. And basically, I'm saying, well, it's rotated, and I scaled it a little bit too because the size of a dot should be 7 millimeters, 0.7 millimeters, 0.7 millimeters, and that's the width of this pencil. And fantastic, that's great. That's shooting the gap, and between that gap, I didn't write any of the A B's yet. You don't really have that configuration space or the need of one with a parentheses because this is a question mark as well. In set theory, you have to understand because it's a question mark, I can add it as an addition or a subtraction or some type of cross multiple of that situation. When we get down here to the bottom, how do I configure what the plus symbol in this case is? Where some geometry of those two things together are going to equal this, which is by scale. What am I doing? I'm rotating, I'm reflecting, I'm conserving, I'm scaling, I'm doing a bunch of different states within there, and it's probably in this wheelhouse most definitely by SI units. Because at that point in time, it doesn't make any sense for me to why I think about kids would need to do that and try to fundamentally figure out what the FG is on some of the math works that I've been looking at. I thought the crop circle, again, I took the pictures of a few of them just real quick. It's not really, I made a joke with them because I feel that they would have been better answers as far as shooting a capybara with a laser beam inside of here to deal with the deflection of a laser beam shot into the sun and trying to deal with his clip force. I mean, that's a really hard thing to as far as what you want to write out. And I love this on the other hand because it serves what that does. You're doing a lot of the same behavioral things with mathematics, but with totally different numbers. And here it doesn't give you any numbers to look at except for the fact that there's a radial. That's going to be 2 pi. And there are a couple of spheres inside here to identify what that problem is. Here we're saying a circle and circle. It's fun with oxygen and fusion and the grains of sand, killing some time with some mathematicians. But realistically, I don't know if I have the physics one in here. I mean, when you read out that equation, you're telling me that that's not what that is. A lot of this is about Milgram's experiment inside of here that explain why a plus b x to this multiplied by to the power of c, right off the hop, where c is the positive integer. As so, I mean, it reads like a psychological experiment, and in a lot of ways you're doing a piece of the set theory from a more complicated index of where that jumps into the equation to then finish it out, which eventually would be omega set or a universal omega set in a situation like that. But how do you get to that? I mean, that's a lot of physical proofs that are different combinations of periods where you're going to write them out like that, and each of them are going to break down, where I'm trying to say, well, that equals this, and that's defined as AC, basically not A naught. That's the total radiant or rads off of that in some kind of 2 pi, where A is being converted back over, And so I just snapshotted in the middle. There's probably more to that equation. And that's the point. I can parrot some of that, and I can conduct that and seem like such as a teacher. But for what reason is this something that's necessary? And you'll separate out some of the A's and the B's from this situation, or the C's in this case, ones that sit up. A's and B's are sometimes hard to tell apart, and they can both generally be the student not knowing what's going on, or the teacher electrocuting somebody and not necessarily knowing what's going on, because they haven't found necessarily the area of that. With that said, doctor, there's parts of this equation that quantify that as well, that some mice might get hurt in this experiment. Well, we're trying to figure out what that experiment is, or the parameters for it would be. Just breaking down some irrational, trying out the pattern and stuff like that. Working with mercury, it's a hot science. But back to those, that's a good point inside here. Those two values specifically, where I'm saying it's cross product or it's a multiple, it's a higher order of what it does, is really defining on the A unit, or the AP or PA, whatever it was inside here. Let's see if we can get back to it. I just saw it a second ago. This. Here we go. This bad puppy right here is what I'm looking for. I need intensity, and I need time, I need feet and force, and in that way I can graph that. Without that thing, I can't tell you from the points, the dot products, what those numbers correlate to as a value P or Y. And it's more about not necessarily that you couldn't define them ontologically, set theory that they are equal with one another, and some parity chirality to it. But more importantly, because it's so Pavlovian dogged already, you should just keep it close to what Py would be, or Px, or in some cases Mg or Hg or Fe, Fr. And you might have to get used to those patterns, but kind of understanding. I'm not saying that this is what it is. It probably needs to be ground down a little bit, because I know it's in some level experimentally true. I've done it with seeds, I've done it with other things. But as far as actually the rigorous nature of some of these variables in Brownian mechanics that's necessary to understand why it's doped and therefore unstable, or because it's doped, it remained more stable than I was expecting in some kind of fashion. I think that's a good note. I'm going to leave it alone for now. But X and Y, remember that this is the idea of trying to form that and getting some combinations of brickworks out of it, and the C1 and the C2, or the CO, C naught. It's in the first order of what the equation is as far as the pattern defines it, before it works out in a series, terminating series, which I thought was fun because I've already used C. It kind of steps on itself, A, B, C, A, B, because it shares some kind of symmetry with a different position. But I needed to serve the A level and the B level as far as A naught and B naught, because now that those positions are somewhere different, it's kind of correlating to these behaviors. Need some work, I'm sure, but some notes to chew on.